All right, this is Chemistry Podcast 5.3, and we're going to talk about how you can predict products of single replacement reactions. So you need to remember back to what a single replacement reaction is. And the general formula that I gave you earlier was A plus BC gives you AC plus B. What you need to remember is that you have an element and a compound, and then two things are going to switch places. So in this case, the A comes in, and it ends up kicking the B out by itself. You need to make sure when you're doing this that it is a positive charge replacing another positive charge, or it is a negative charge replacing another negative. So what you're going to look for is the one that's by itself. If the one by itself is positive, it's going to replace the positive that is in the compound. There are the two that are going to switch places. If I have this reaction again, but if the A is the negative charge, then it's going to replace the negative over here. So in this case, the products would be C by itself and then BA. So you just need to double check charges. We're going to be using your activity of metals series, which metals are always positive. So you're usually going to have the positives replacing the positives. In a few cases, you will have the negative going to the negative. And that's where you would use the back of your periodic table under the activity series list. There's the top section that has all the positives, and then there's a separate section right under it which has all your negatives like chlorine, fluorine, chlorine, bromine, all your halogens. So here's what your activity series of metals looks like. You need to understand that not all reactions are going to take place. If you're reacting a more reactive metal with something else, then yes, it will happen. But if you're putting copper into like lithium chloride, that's not going to happen because copper is not more reactive than lithium. So the most reactive metals are at the top, the least reactive metals are at the bottom, and what you're looking for is that the most reactive metal is in the compound. That's where it wants to be, and that's where it's going to be. So the element that is the highest on the list will be in the compound. The most reactive metal needs to be in the compound. That means if it's already there, then nothing will happen. No reaction will take place. So let's do some of these as an example. I have iron 3 chloride and I'm putting it into lithium. Or I'm putting lithium solid into iron 3 chloride. Lithium is a metal, it's a positive, so I'm going to be looking at it compared to the iron 3. If you go to your activity of metals series and you look, you're going to see that lithium is at the very top. That means it's more reactive than anything else. So since it's more reactive, it's going to want to be in the compound with chlorine more than iron is. So you're going to get the products. I'm just going to rewrite this. You're going to have iron 3 chloride, aqueous, and lithium solid. This reaction will happen. The lithium is going to join with the chlorine, and remember lithium is a +1, chlorine is a -1. That always is your aqueous. So for these, your compounds will always be aqueous, plus the iron metal is going to get kicked out by itself. And then to balance, we would put a 3 here and a 3 here. So that would be your written reaction for what happens between solid lithium and iron 3 chloride. The next one is between potassium phosphite and calcium. So I'm going to compare calcium and potassium to each other. And if you look on the activity series, you're going to see that potassium is higher than calcium. And since potassium is higher and it's already in the compound, this is a no reaction. Nothing will happen. Potassium's already where it wants to be. All right, my next one here is phosphoric acid and calcium. And you may be wondering, what do I do because there is no metal here? but we're actually going to use the hydrogen because if you remember, hydrogen has a plus charge and it's on your activity of metals series list. So if you go down there, you're going to see hydrogen towards the bottom and calcium is going to be up towards the top. So calcium is more reactive than hydrogen, which means calcium is going to want to be with the phosphate more. So what you're going to do is you're going to, well, I'm going to rewrite it first. I am going to put the calcium with the phosphate, and I'm just going to write the charges up here so we remember when we're putting them together what they are. Calcium is a +2, phosphate is a -3. So it'd be Ca3PO4 2, and that's going to be aqueous because it's the compound, plus the hydrogen is going to get kicked out by itself. Hydrogen we know is a diatomic, so it's going to be H2, and H2 hydrogen is a gas. So in this case, we're going to see bubbles coming off. You're going to see hydrogen gas being produced. And then you could go back and balance this. We could put a 2 here, which gives us 2 phosphates. We need 3 calciums, and we need 6 hydrogens, so we'd put a 3 there. So there's your balanced reaction for that. The next one we have is iron reacting with aqueous nickel 2 chloride. All right, iron is a solid plus nickel 2 chloride. Nickel, because of that right there, tells me that Roman numeral is a +2, chlorine is a -1. That's aqueous. To produce, I need to check, is iron higher than nickel on my list? And it is. So iron is going to want to be with the chlorine more. And the iron that I use is iron 3. So iron with a +3 charge means I need 3 chlorines to go with it. The nickel is going to get kicked out by itself. And then to go back and balance, we would just throw all those in. So that reaction will happen. So we have another one. Lithium bromide. Lithium and bromine are +1, -1. Reacts with solid iron. So I'm going to check. Lithium is at the very top of the list. It's the most reactive, and it is already with the bromine. So this is going to be a no reaction because iron is not more reactive than lithium. Aluminum nitrate. Aluminum is a +3, nitrate is a -1, and when I need it, maybe barium will be a +2. But to write this out for now, aluminum nitrate, and I'm going to need 3 of them, reacts with solid barium. And remember, since it's barium by itself, I don't worry about the charge yet. I look on my list and I see that barium is higher up on the list than aluminum, so barium is going to come in and kick the aluminum out by itself. So we're going to end up with solid aluminum plus the barium is going to join with the nitrate, and it's going to be aqueous. So then to balance, we would do this. So there's your final balanced reaction. Okay, that's all the practice we're going to do together with the podcast. We're going to do a lot more in class. The big thing to get from this is from the activities series that the most reactive metals are on the top of the list, and they are the ones that are going to be in the compounds. The least reactive metals are at the bottom, and they are the ones that you need to make sure are by themselves.